This is a video on rates of change, and it's about how to estimate the instantaneous rate of change, and we're going to be introduced to the difference quotient. Okay, so here we've got a curve, and let's just say eventually we would like to estimate the slope at one point on this curve, so like right here. So we talked about how we could approximate it by picking another point on the line, taking the secant, or that's the secant, and finding the average rate of change between the 2 points. So we're just going to redefine our notation for this situation. So you know how before we talked about how if you wanted to find the rate of change, you use the formula y2 minus y1 over x2 minus x1. And then we also said you could write that in function notation, which would be f of x2 minus f of x1 over x2 minus x1. So just rise over run. So we're still using that exact same formula, but this time we're just going to rename our points. So I'm going to name this point down here. I'm going to name that point on the x-axis. I'm going to call it point A. So the x value of that point is A instead of like x1. And then I'm going to call the y value of that point f of A. So that point is at A, f of A. So that's that point. That's that coordinate. And then the top point, this guy up here, I'm going to say it's a certain distance away from A. So instead of using a new letter, well, I guess I will use a new letter, I'm going to call that point A plus H, where H is just the distance away that A is. So for example, if I wanted A to be 2, and I wanted this point over here to be 3, that would mean that H is 1, because that's how far apart these points are. So this point is like 2 plus 1, which is 3. So H is just the distance away it is from point A. So if I wanted to label this top point here, I would call it, the x value would be A plus H, and the y value would be f of A plus H. So that's how I'm going to label my 2 points. So when I'm finding the rate of change of them, the rise over the run, to get the rise, I'm just subtracting my y values. So f of A plus H minus f of A. And to figure out my x values, I'm just subtracting, to figure out the run, I'm just subtracting my x values. So A plus H minus A. And you can see what happens with the A plus H minus A. The A's are going to go away because A minus A is nothing. So that interval will just be H long, which makes sense, right? Because this is A and this is A plus H. So the distance between them is H. So instead of using these slope formulas, we're going to switch and use this one, which we call the difference quotient. So it's just the rise over run. So f of A plus H minus f of A divided by H. I'm just going to actually write it out. So it would be divided by A plus H minus A, because I'm subtracting my x values, which is going to simplify to just an H on the bottom. And we call this the difference quotient. And it's used to find the slope of the secant. And we can use it to estimate the instantaneous rate of change at a point. So this is called the difference quotient. So as our interval gets smaller and smaller, we can better estimate the rate of change at one point. So like, let's say we're trying to find the rate of change just at this point. So the secant gives us a good estimate, but the closer that pink point gets to that blue point, so the closer and closer and closer it gets, like if it was right beside it, that would give us a better estimate of the instantaneous rate of change at point A here. So the closer point A gets, the closer the pink point gets to A, the better our estimate for instantaneous rate of change. So that's also saying the smaller h gets, so the smaller this interval, the better we have it, the better our estimate for instantaneous rate of change. So we can use the difference quotient to find the slope of a secant and to estimate the instantaneous rate of change. So let's say we had an equation like f of x equals 2x squared plus 1. I think we did this one in class. So f of x equals 2x squared plus 1. And let's just say we wanted to find the average rate of change between like 1 and 3 on the x-axis, between x equals 1 and x equals 3. Maybe we had to find a few average rates of change, maybe between like 4 and 5 and 7 and 9. You could actually use the difference quotient and then just sub your information in at the end. So if I was going to use the difference quotient, this is how I would use it. So it's f of a plus h minus f of a, all divided by h. So what I'm doing is I'm subbing in an a plus h for x. So basically anywhere you see an x, you're going to replace it with an a plus h. So for the first one, I'm going to put it in square brackets. So for just this part of the equation, I will do 2, instead of an x, I'm going to put in brackets a plus h squared plus 1. That's my first part. That's f of a plus h. That's that. Minus, so we subtract f of a. So now I'm replacing the x with an a. So I'm going to put this in square brackets again. So 2, instead of x, I'm doing a squared plus 1. So I just subbed a plus h and a into this original equation for x. And then the whole thing is divided by h. And now your goal is to just simplify as much as possible. So I need to expand the brackets. So just a reminder that if you're expanding a plus h squared, that is a binomial. So a plus h times a plus h, you're multiplying binomials. So you're multiplying a times h times a, h times h. So that expands out to a squared plus 2ah plus h squared. And then I have plus 1. And then I'm going to get rid of my square brackets, so I have to distribute the negative throughout that bracket. So it would be minus 2a squared minus 1. And then the whole thing is divided by h. Now I'm going to multiply my 2 through the brackets. So I have 2a squared plus 4ah plus 2h squared. I'm just going to get rid of those 1s because it looks like I have a plus 1 and a minus 1. So I'm just going to get rid of those. So minus 2a squared, and the whole thing is divided by h. Okay, next step, just going to keep simplifying. So the 2a squareds are going to go. All I'm left with is 4ah plus 2h squared divided by h. I'm noticing that every term has an h in it. So I'm going to common factor out an h on top, leaving me with 4a plus 2h divided by h. And then the h's will cancel out. So I'm just left with 4a plus 2h, which is the slope of the secant. So a is the point that we're trying to, like the a is like that point on our curve, and h is the distance to the next point. So if I wanted to find the average rate of change between, what do we say, 1 and 3 seconds. So So let me just sketch this out for you. So I've got a graph. So my original function is 2x squared plus 1. So that's going to be like something like this. It's a parabola. So if I'm trying to find the average rate of change between, what do we say, 1 and 3? So 1, 2, 3. So I'm trying to find the average rate of change between this point and this point. So I'm finding the slope of the secant. So I can use 1 as my a value. So my a value is 1. I just picked one of the points to be a. And then my h value is going to be 2. Because since I'm finding the average rate of change between x equals 1 and x equals 3, so that the distance between those 2 points is 2, right? From 1 over to 3, that's a distance of 2 units. So to find the average rate of change, I just sub in 1 for a and 2 for h. And there we go. So it'd be 4 plus 4, which is 8. So my average rate of change between 1 and 3 would be 8. And I can use this formula to estimate the instantaneous rate of change. And to do that, I'm just picking smaller and smaller and smaller and smaller values for h. So let's say I wanted to estimate the instantaneous rate of change at x equals 1. So if I want to estimate the instantaneous rate of change right there, that means I'm looking for the slope of the tangent. I am going to pick 1 is going to be my a value, and I just want h to be really small. So maybe I'll start picking values to the right of my point and to the left of my point. So using the difference quotient answer that I got, I will just try different things. So I'll try, I need a to be 1, and then h maybe is 1.0001, and then I'll see what I get. And then I'll try it again, but maybe I'll pick a point that's close to 1 on the other side. So maybe I'll pick 0.9999 and see what that equals. And I can keep picking points that are really close to 1, but on either side of it, and just see, I don't have a calculator, so I don't actually know, but just see what it's approaching. And I think I will notice that it's actually approaching 4. So the slope of the tangent line at 1 would be equal to 4. And that is the difference quotient.